Surface area of right pyramids and right cones. We've done volume, now surface area. Remember, the surface area of any object is the total area of all the surfaces of the object. And yes, I sometimes call it the exposed surfaces, and we will get into a definition in just a moment that deals with that. Review. State a formula that can be used to determine the surface area of each of the following shapes. Okay, so the area, we've got these two circles, and then we've got the lateral surface there. So surface area is 2 pi r squared, two circles, plus, now remember this thing folds out into a rectangle, and you can look back of 2 pi r, whose base is 2 pi r, and whose height is h. Surface area here, we have three sets of two, the top and the bottom are the same, the left side and the right side are the same, the front and the back are the same. So the surface area, there's 2 length widths plus 2 width times height plus 2 length times height. Or if you like, 2 and then just do all these together, length width plus width height plus length height. And the surface area of a sphere is 4 pi r squared. Okay, let's review. You've got those written down. We're going to use those. Wow, colorful. It's not so colorful on your sheet. Surface area of right pyramids. If you think about the surfaces of a right pyramid with a rectangular base, we have these 2 orange triangles, which are the same size. So there's 2 of them. We've got these 2 purple triangles, which are the same size. And then we've got the base itself, which is the width times the length. And so there's a slant height here, and there is also a slant height here, and it's going to be different. Like this is S1, and this is S2. So there will be 2 different slant heights. That can make some of these fairly interesting to figure out, or a bit of work. If we talk about the lateral surface area, we're talking about the sum of the surface area of all the object's faces, excluding the base. So if we think about a pyramid, just think that it's resting on its base. It's a pyramid in Egypt, and it's resting on its base. And if we want to figure out the area, we're really only interested in the area of the triangular faces. So the lateral area of the rectangular base pyramid is the surface of all 4 triangles. And what do you notice about the slant height of the pyramid? We notice that the slant height here will actually be different from the slant height here. Let's call that S1 and S2. The slant height goes up the face of the pyramid. And then this distance here is half of this distance, whereas this distance here is half of the distance here. And they will be different. The height will be the same. Height is constant. But since these base measures for the 2 triangles are different, our slant height will be different. So it runs up the face. Face of the pyramid. And if the base is a rectangle, there will be 2. Different slant heights. Right, if the base is a square, you only have 1 slant height. Example 1, a right pyramid has a square base. This makes life a little bit easier, since with a square base we will have the same slant height on all 4 faces. If the slant height of one of the side surfaces is 15.3 inches, then actually they are all 15.3 inches. Determine the surface area of the pyramid to the nearest tenth. Okay, so the surface area is going to be the lateral surface area plus the surface area of the base. Okay, so remember the base is what it's resting on, in this case the square base, and the lateral area is the area of the triangular faces. So if I can draw a picture, which I probably can't, at least not well. And we know this is 10.2. This is the slant height here, so it's 15.3. So the lateral surface area, there are 4 triangles. The area of the triangle is 1/2 base height. And the surface area of the base is b squared. And in this case, the bases, that's b, and we'll call that, actually, you know what, let's not call that h. Let's call that s for slant height. So s is equal to 15.3 inches, and b is equal to 10.2 inches. Okay, 4 times 1/2, 10.2, slant height 15.3, plus b squared, it's a square base, so 10.2 squared. 4 times 1/2 is 2. We can just work this out. We've shown everything now. And to the nearest tenth, 416.2 inches squared, right? Square inches, because this is an area, right? An area is measured in square units. Dang, I guess I skipped example 2. Example 2, a right pyramid has a rectangular base that measures 14 centimeters in length and 6 centimeters in width. If the height from the base to the apex of the pyramid is 20 centimeters, then determine the surface area of the pyramid to the nearest whole number. Okay, and now notice this time they're giving us the height of the pyramid. So let me see if I can draw something out. 14. Oh, let's call that 6. We'll call this 14. Actually, I want more of a perspective drawing, don't I? So, okay. Wow, that's lousy, isn't it? Okay, that's your 20. That's 14. That's 6. Oh, lovely. And I can see that when I worked this out on paper, I put the wrong number down. All right, basically what we're going to have is 2 slant heights. Right? We're going to have a height of 20, a base here, which is half the 14, so base here, which is 7, and then a slant height of this face and that face. So we'll call that S1. We are also going to have the slant height of this face. So from the middle here, moving out, you see that 6, this will be 3 and 20. So we're going to have another pyramid, or sorry, triangle. Well, this is 20, and this is half of 6, which is 3, and this will be S2. So let me see if I can squeeze this in here. S1 squared will be 20 squared plus 7 squared. S1 squared is 400 plus 49. S1 will be the square root of 449. S2 will be, or S2 squared is 20 squared plus 3 squared S2 is the root of 409. Okay, so we now have our two slant heights. And we're going to have two of each face, right? We have two of this face, and we have two of these guys here. And just think back to the diagram. Let's see if we can pop back. Yeah, think back to here, right? This is where this is 7, and the height is 20, and then we want to work out the slant height, and this is where this will be 3, right? So we have the two purple and the two orange. Let's put back down here. Okay, so surface area is the lateral plus the surface area of the base. The lateral surface area consists of two triangles, which are 1/2. Now the base will be 14, and where the base is 14, the slant height will be root 409. So 1/2 14. I suppose really Mr. Formula here, right? So, okay, let's say 1/2 B1 S1 plus 2 times 1/2 B2 S2. Right, so we've got one base which is 14, and that has a slant height of root 409, and we've got one base which is 6 and has a slant height of 449, root 449. Okay, and that's the lateral surface area, and then the surface area of the base will be B1 times B2. Okay, let's fill in. While we're filling in, we can simplify. 2 times 1/2 is 1. So it's base 1, 14 times the root of, this is the base, the height is the one that has the little 3 here, right? The height is this, so it's root 409. Plus 2 times 1/2 again is 1. Base 2 is 6. This has the longer, right? Because now it's got this 7 and the 20. It's this slant height here. I think I mixed up my B1s and S1s, but so 2 times 1/2 is 1, so this is 6 root 449. And B1 and B2 are just 6 times 14, right? And yeah, I'm not really going to do a lot of simplifying. Let's just work this out. So we have 14 second root 409, arrow over to get out from under the root sign, plus 6 second root 449, again arrow over to get out from underneath the root sign, plus 6 times 14. And doing this to the nearest whole number, so 494. And I cannot remember the units. They are centimeters, so 494 centimeters squared. Surface area of a cone, a right cone. So think about the surfaces of a right cone. We've got the base, which is a circle, and the rest of it, you know, the thing that isn't the base, again, we call that the lateral area, right? And this chunk here, you know, if you cut it, you know, if we cut along the slant height here and unfolded it, then this is what it would look like. Where does it come from? How do we get the lateral area of the cone? If we start with a square-based pyramid, such as the one on the far left here below, then the lateral area is made up of 4 triangular sides. If the number of the sides of the base is increased, so what if we go to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. If we go to 6 sides, now we have 6 triangular sides, right, making up the lateral area. So if the number of sides in the base is increased, then the number of triangles making up the lateral area is also increased. Keep increasing the sides in the base, and eventually the sides are so small. So look, here we have, I don't know, lots. And if we make them smaller, then eventually the base, instead of becoming, these little straight lines, becomes a circle, and the lateral area of the cone is formed. And this is also something that we do a bunch in mathematics, and here's sort of your first taste of it, I guess. Each triangle in the lateral area of the shapes has the area 1/2 base times slant height. Remember, it's the slant height measured along the face, where b is the length of each side in the base, and s is the slant height of the pyramid. So remember, these are regular, right? In other words, this is a square, this is a regular pentagon, so all of these slant heights are the same. So for the four-sided base pyramid, the lateral area has the equation 4 times 1/2 base slant height. But 4 times 1/2 base slant height is 1/2 s. If we take the 1/2 s out there, we're left with 4b. And 4b is the perimeter of this base, right? It's the distance around. 1, 2, 3, 4b. Perimeter. So the lateral area is 1/2 s times the perimeter of the base. If we extend our thought process to each of the shapes shown above, the same process occurs. Therefore, the lateral area of the cone is given by 1/2 s times the perimeter of the base. The perimeter of a circle has a special name. It's called the circumference. The formula for circumference is 2 pi r. 1/2 s times 2 pi r, the half this go, and putting things in order, we get pi r s. So the lateral area of surface area of the cone is given by pi r s. So the surface area of the cone is the area of the base, let's call that S A base plus S A lateral. Using variables, the area of the base is pi r squared, and the lateral area is pi r s. So this is the surface area of a cone, or the formula for the surface area of a cone. Let's use it. Example 3. A right cone has a radius of 3.5 feet. The height of the cone, remember that's height as in the distance from the base to the top point, to the apex, is 6.7 feet. This is not the slant height. Determine the surface area of the cone to the nearest hundredth. So if we draw this out, there's my cone. It has a radius. That's a 90. So this is 3.5 feet, and this is 6.7 feet. So let's strip that triangle out of there. This is 6.7. This is 3.5. This is S, the slant height. So we know that S squared is 3.5 squared plus 6.7 squared. S squared will, let's just go to S. So S is the square root of 3.5 squared plus 6.7 squared. So S is the square root, and we want exact, never round, right? You know this now. We never round. Well, that's not true. We round as the final answer. Surface area formula, pi r squared, that's the circular base. So if they ever ask for just the lateral surface area, you're leaving this out. Okay, so just make sure you can distinguish between when in a question you'd be asked for surface area or lateral surface area. So pi, fill it in. Radius is 3.5 squared plus pi. Radius is 3.5. And the slant height is the square root of 57.14, which shall remain unrounded for now. Okay, and then plug this in your calculator. You get to the nearest hundredth, 121 4.60 feet squared. Now at this point, pause the video if you're watching it and go work this out. Because there's two things. This might be wrong, or not or. If it is, please let me know. But if it isn't wrong, then make sure that you're able to get the same answer. You always want to verify each of your calculations. Just make sure you're using the calculator correctly. Don't assume you know how to use it. There are sometimes some tricks in the calculations or brackets that need to go in and stuff, so just make sure you're working it out correctly. A right cone has a surface area of 210 centimeters squared if the diameter of the cone is 9 centimeters. Well, as soon as I read that, I'm going to say r is equal to 4. I'm not even reading on. I know I need a radius. Okay, then radius is 4.5. Determine, show your work, the slant height of the cone, and then the height of the cone. Round answers to the nearest tenth. Okay, so remember, we're going to do that. We will round this, but we will use the full value we worked out for this in order to find the height of the cone. Okay, so let's start with the formula. What do we got? Surface area, pi r squared plus pi r s. I could draw this. We could label it. Let's go draw this. That's 4.5. That's h. This is s. And I think all we know is the 4.5 and the area, right? Okay, so filling in numbers. Formula, substitution. Pi, we do know r. Plus pi, we do know r. We do not know s. But the only thing we don't know in here is s. So using our first day skills, we're going to solve this for s. So let's do a little calculatorless math. 4.5 squared is 20.25. If you want to know how to square a number ending in 5, ask me. I'll show you how. Plus 4.5 pi s. Now, in order to isolate the s, we must first get rid of this. And the way we're going to do it is by subtracting it from 210. And I'd like to reverse sides at the same time. So I'm going to say 4.5 pi s is equal to 210 minus 20.25 pi. So s is equal to 210 minus 20.25 pi divided by 4.5 pi. Okay, and you plug this into your calculator. Let's plug this into our calculator. So remember, we're going to need brackets around the top. All right, here, let's clear this out of the way. So we're going to go bracket 210 minus, now if you want to, you could have left that as 4.5. So let's go 4.5 squared pi, close bracket, divided by, open the bracket, 4.5 pi. Hit enter, because we want to keep that number. S equals, we want to keep that number, and I made it disappear. 10.35446, 10.35446, dot, dot, dot. Right? That's how we're going to show. We're going to show, hey, look, I didn't round it. Okay, I will when it comes down to it, but it's not yet. I didn't round it. I'm now going to go over here and say that h squared plus 4.5 squared is s squared. See, that's why we don't want to round this. If we round it, we're using a rounded value here. This can throw off our actual value for h. So h squared is s squared minus 4.5 squared. So let's go 10.354 dot, 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 squared minus 4.5 squared. Square root of 10.354 squared minus 4.5 squared. Okay, so how do we do this on our calculator? We have the number sitting here, right? We want to take the square root, so second function, root. I need this number squared, so I'm going to go second function, answer. So it's going to bring down that number squared minus 4.5 squared, right? All under the radical sign. And there's h, 9.325, 9.325, dot, dot, dot. And so now we can give our values. Okay, so the slant height S is 10.4 centimeters. Okay, now we're rounding. 10.35 rounds to 10.4, and H is 9.3 centimeters. Okay, rounding only the final value of H, not using a rounded value of S to calculate it. It'll throw this off probably, and then that will throw your mark off because on a numeric response it will just be wrong. And it looks like we are done this one in under 26 minutes.